Welcome everybody to Summer Community Days. This is day number 2, and you are currently in track 3 where you'll be hearing technical talks all afternoon. We are first hearing from Madison Schott. Madison is the analytics engineer at Winc, and a couple fun facts about her. She also works as an academic mentor at the Crimson Scholars. She's been a data writer for 6+ years. You can find some of her work on the Census blog. And before this, she was an associate data engineer at Capital One. So before she gets started, just so you guys understand the platform a little bit, on the right side of your screen, you have the chat and Q&A. If you have any questions for Madison throughout her session, you can add them to Q&A and we'll answer them at the end. And all other chatter can go in chat. And last thing, since this conversation talks about DBT, we have a fun poll for you guys. And yes, this is live, so you can answer these questions right now. Have you implemented DBT in your organization? Yes, no, also acceptable, not our business. So let's see who we got. All right, so this is mainly a DBT audience. Beautiful.
That is definitely good to hear.
Yeah, perfect. Okay. Madison, I will share your presentation again. And thank you so much, Madison. The floor is yours.
The only thing worse than bad data is no data at all. Today I'm going to show you how to never lose days, weeks, months worth of data again with this free DBT package called RE Data. But first, a little bit about me. I'm an analytics engineer at Winc, where I rebuilt our entire modern data stack using tools like Fivetran, Snowflake, DBT, and Prefect. Currently, I'm working on a data quality initiative, which is one of the reasons how I discovered RE Data. So I've been working on putting a lot of different monitoring tools in place and figuring out ways to improve the quality of our data for our business. I'm also a technical writer where I share my experience as an analytics engineer. I write mostly on Medium, which I share tutorials on different technologies that I use and problems that I've solved and best practices that I've discovered work super well for me. I also have a newsletter where I share more about my story coming into the data field and again about technical findings, a lot about DBT, so it's good to hear that most of the people watching are DBT users. And if you're not, hopefully I can convince you to use DBT by the end of this. And then I'm also a wellness enthusiast. I'm super passionate about health, wellness, fitness. You'll see different wellness-related articles sprinkled in with my data content on Medium. Something that I'm excited about is recently I was able to do my first headstand and actually keep my legs all the way up in the air. So that just happened like 3 days ago. So I've been very excited about that. And that's been something I've been working on for a while. So now into the presentation. So this is pretty much an analytics engineer or data engineer's worst nightmare, seeing our volume count of our data drop to 0. A lot of times this can go undiscovered for days, weeks, months, which is a pretty awful thing to come upon, to realize that you haven't collected any data for the last week or month or whatever it is. When I first came across this problem with our data at Winc, I think it was 2 weeks had gone by where we hadn't realized it, and I was actually working on a different problem at the time. And something looked a little weird, and I came across the fact that we weren't actually ingesting any data into one of our data tables. So I discovered RE Data while looking for a solution to fix that and make sure that that problem never happened again. So what is RE Data? RE Data is an open source data reliability tool that works directly within DBT. It integrates directly into your DBT project.yaml file and the SQL files that hold your data models. So if you're already using DBT, this is super easy to implement and it's free. I always try and go for the free tools to save some costs. And I think that there's a lot of great options out there in the open source community, and this is just one of them. RE data calculates different table metrics as well as column metrics. Some of the table ones include data volume and freshness. Data volume is the one that we'll specifically be focusing on today. And then it also looks at different metrics based off of your columns like aggregates, null values, standard deviation, length, and more. So how does RE data work? These are two tables that RE data creates within your data warehouse. The first is an example of the metrics tables that it creates. So here you can see it's creating the metric values for row count, which is what we're going to look at today. That's specifically focused on data volume. And you can see that it has a value, which is just the number of rows in your data table. And then it also includes the window of when the data that this row count was calculated for. So this is a daily metric in this case. And then it also gives you the exact date and time that it was computed. This bottom table includes the statistics that RE data calculates, and this is what it uses to detect anomalies within your data. So you can see it calculates z-score, modified z-score, average, median, IQR, so different statistics to help you really understand your data. And it actually uses the rows in that first table to calculate these statistics. So depending on the rows that you have available in that first table is what it will use to calculate like z-score, median, mean, IQR. So what does RE data actually look like when it's implemented? This is an example of a Slack alert that it creates. So this will be sent directly to your Slack channel to tell you about your different anomalies. I'll show you how to set this up using Prefect at the end. But it shows you the name of the data model. So in this case, we're looking at the web event clicks model, and then it'll show you the different anomalies. So it shows you the metric that is being calculated and the percentage, either less or more, that it deviates from the average. And then it'll also give you the specific value. So you can see how many rows of data you're actually ingesting. And this will also give you a good idea if this is a anomaly that you really need to look into closely, or maybe one that isn't a big deal, but actually came up as an anomaly within the table. And then the time window shows you when this metric was calculated. So the way I currently have Slack alerts set up is that it sends them for every week. So each day I'll get an alert of any that have happened within the last week. And I'll also show you how to do this more within the Slack command at the end. So now let's get into the tutorial and how to actually implement RE data. So downloading RE data is a really easy process, especially if you're already using DBT. A lot of data observability or monitoring tools can have a pretty hefty setup process, but this is really something that you could implement in one day within your DBT project, which I think makes it really powerful because it's something you could literally act on right after this talk if you wanted to. So you simply add the package name to your packages.yaml file within your DBT project. You might already have other packages in there, such as Fivetran or Prefect or DBT expectations. And then you run dbt deps, which will install all of the dependencies that are required with RE data. And then lastly, if you want to utilize Slack alerts like I just showed you in the previous screen, you're going to want to install this using pip. And RE data also has a UI. I personally don't use the UI because I want my alerts to show up in a place that I'm already checking every day. I don't really want to have to check another platform to see what my data is looking like. But that's a great option if you also want to use that. So setting up your DBT project.yaml. So RE data is basically a DBT model. So you set it up kind of like you would a regular DBT model. You just define it under the models block within your DBT project.yaml file, and you set the enabled block to be true. And then also within the same dbt-project.yaml file, you want to define some variables that REData is going to use to do all of these calculations and generate these tables within your warehouse. So one of those is the metric space. These are the different metrics you want REData to calculate. So we kind of went through these in the first few slides. They have column level metrics and they have table level metrics. Today, we're just going to be looking at row count, which is a table metric. So I have row count listed under the table block here because I want REData to calculate row count for all of my data models where I specify REData. So any metric that you define under the table or the column block is going to be calculated every file or every data model that REData is defined. So if you only want a metric to be calculated for like one specific data model, you can actually define that within the configuration in the data model itself, which I'll show you on the next slide. But these are good for just universal metrics. You also want to define the anomaly detector. So this is either going to be a modified z-score or a z-score, depending on what you choose to use. So I have modified z-score here, but I actually use a z-score for our data at Winc. Modified z-score is less affected by outliers in your data, whereas modified z-score is more affected by outliers in your data, whereas z-score is less affected. So I personally choose to use z-score because I would rather be alerted for anomalies that aren't that important rather than not be alerted of anomalies that are really going to affect the quality of our data. And then you can also determine the threshold. This will determine when you receive alerts. So if you set a threshold of 2, you'll receive alerts for any z-score outside of the range of -2 or +2. I personally set this to 1 because after using REData for a while, I was looking back at a lot of our data and looking at our anomalies and what the average z-score was for row counts that I really wanted to be notified by. And it came out to around 1.5. So I determined my threshold should be 1, just so I'm receiving those alerts and can look into anything that might be unusual. But this is something that I recommend doing as you use REData because it's only generating these rows for how long you have it running. It's going to get smarter as it goes and more representative of your data the longer you're using it. And then I also have the anomaly detection lookback days. This determines the number of days you want your REData to look back and calculate z-score for. So if you remember that first table, metrics table that I showed you earlier, it would use 30 of those rows or 30 days worth of data to calculate the z-score. So this is something that I actually recently changed within our data models, is that I increased this number to 90 because you want to have as many rows of data going into this as possible because it's just going to be more representative of your data. If you're only using 30 days or like 10 days, then you're really not getting a good read on what your data looks like on the average day. However, if you only have like 3 rows of data in your table, it's only going to use those 3 rows of data to calculate this. So again, you kind of want to just keep using it, and the longer you use REData to calculate these metrics, the more accurate it's going to be and the more dependable. So this is an example of the config block that you then have to add to the individual SQL file or the data model. So this will just go at the top before any of your SQL code that you wrote in that specific file. So you want to set REData monitored equal to true, which just tells you to monitor this data model essentially. And then the REData time filter is going to be a timestamp that it uses to determine the window of the calculation. So you really want to use a timestamp of when your data is actually being generated. And if you don't have a timestamp column, you can use something like the 5tran sync timestamp if you use 5tran to ingest data. Most ingestion tools will have a timestamp similar to that. And I also include all of these in my base models just to do the monitoring at the source, but you can also do these in any other data models you have as well. So REData creates a few different tables as well as views in your data warehouse. Here's an example of a few of them that it creates. So you can go back and look at these metrics. When I was doing my deep dive into the z-score that I wanted to use, I was looking through these tables to look at past anomalies and metrics to figure out what I wanted to set that threshold to. And an important thing to keep in mind is that it's going to create an REData schema with these tables and views in the default database that's specified in your profiles.yaml within DBT. So you might have to do some reconfiguring depending on where you want that REData schema to be created. So running REData. REData runs just like a DBT model, which makes it super easy. So you literally just run it with dbt run --m REData, and it'll generate all those tables and views and perform the calculations it needs to do. So I personally use Prefect for my data pipeline. Prefect is just an automated orchestration solution. I've written a lot about Prefect because I'm a huge fan. So if you want to learn more about Prefect, I'm always happy to send you a few of my articles that I've written. It's a great tool, and that's what I'm going to show you today to use with REData in order to get the Slack notifications. So within Prefect, again, I run REData just like I do any other DBT model. I define it within a DBT task, and I specify the command, so the run command. And then task args is just the name that you want to show up on the Prefect UI, so it makes it cleaner and easier to detect which task is which. And then the Slack alert, again, I run this exactly like I would any other DBT model. It's already created within the REData package, and it's just REData notify Slack, and I run this within a DBT task, again on Prefect. And there's two things you have to specify here. One of them is the end date, which you kind of saw with that Slack alert that I showed as an example. You saw that you received the alerts for the last week. So this basically says, show me the alert for today and any alerts that occurred in the last week. So I personally think this is a best practice because a lot of the times I think we can get alerts and maybe not pay attention to them because we don't look at them as super important or something else comes up. So by having them run for a week, we're kind of reminded to go in and check on those alerts and really investigate what happened. And then the webhook URL is just the specific channel that you want the alert to send to on Slack. And then with Prefect, you also have to set upstream and downstream dependencies. So here I set an upstream dependency of that original REData run with that Slack alert because you want the REData to run before the Slack alerts run, so you're actually getting an accurate read on whether there were any anomalies or not. So this just ensures that the REData model runs before the Slack alert sends. And that is it. If you have any questions, you can always reach out to me on LinkedIn. I post a lot on there, and I always answer any questions that come into my messages. And also check out my Substack for more on my personal data journey, things I've learned along the way, and around analytics engineering in general. Thank you. How many alerts do I get per day? Usually only one or two, if that. Ideally, no alerts. but most of the times there will be at least one. There's a few tables that I think are the most important that we really keep close tabs on, and then there's a few other tables that I think the anomalies aren't as important to keep tabs on.
Thanks, guys. Okay, so, perfect. Madison added her Substack right there. It was on screen. Perfect. And so how many alerts could you answer that again? I want to hear that one. How many alerts do you receive per day?
So usually one or two, if that, but ideally none.
Okay, so that's even when you have your Z-score set to where like you should receive a lot of alerts for like, okay, great.
Yeah, because I only have them on tables where it's necessary and it's going to affect the business. I don't recommend putting alerts on every single table just because then you're just going to be bombarded with alerts. And then I think it almost makes you not check any of them rather than the ones that are super important and key to the business.
Okay, perfect. And then the next one, similar from Eva, do you use different Z-scores for different models or do you use one globally for all models? That's a great question.
Yeah, so if you define them in the dbt project.yaml, like I did, it's going to use that same z-score across all the models. But if you want to use different z-scores, you can specifically define it in the config at the top of each model and use a different one. So I currently don't use any different z-scores, but I think if you were receiving a lot of alerts for one that might have been like a false positive, then I would definitely go in and change them so I'm not getting bombarded with alerts that aren't really true to what's happening.
Okay. And a question from Ella W. Do you use RE data? Is it RE data? Is that how you pronounce it?
I say RE data, maybe RE
Okay.
data.
Do you use RE data as your sole testing package or do you use others as well? How does this package compare to DBT expectations?
I definitely use other ones. I use DBT expectations and DBT tests as well. I personally use RE data mainly for the data volume, just because I haven't seen that used by any other testing packages, and it was something that I was specifically looking for to solve this problem. So, yeah.
Great. Madison, thank you so much. That is the end of this session. Stick around next. We are going to hear from Alan Campopiano. Other than having the coolest last name ever, he is going to teach us a lot about Snowpark on Snowflake and how to use Python with it. So stick around and we will be back in a couple minutes. Thank you, everybody.